Yes, please welcome Mr. Don, CEO Eco and Company Israel. He will present about the latest innovation in agriculture. Please.
Good morning, everyone. It's a pleasure to be here and to see all of you. And I would like to thank Mr. Vishwanath and Mr. Balamurgan for inviting us here. It's our pleasure to be here and to see this association of friends and business associates, which, in my opinion, that's the best way to move forward on innovative technologies when people are trusting each other, and it can go further. So thank you for inviting me. I will take this opportunity to talk about what we're doing in an overall aspect and not getting into the technical side of the things, just to understand where we're coming from and what we are doing. So we are coming from Israel. Israel is a very small country with very limited resources. So we need to use our brains, and we need to come up with technologies that can support our life in Israel. Israel is situated in the Middle East. So first of all, we are used to the heat. So we can deal with that when we're coming here. And Israel, again, is a very, very small country. We're talking about 7-8 million people, which is even less than Chennai, just for your consideration. But agriculture in Israel is a very important and main issue, because farmers are not only farmers, they are also guardians of our borders. If you look at the map and you see the farms, they are all located around the country and basically keeping our borders safe. I don't know how much you know about the Israeli history, but we are surrounded by enemy countries that basically don't want us to be there. So the farmers are sitting on the lines, doing a very hard work, and also keeping those borders safe. I'll give you an example. In Arava area in Israel, which is a desert-like place, where we conducted all of our work, we chose the most difficulty place to try our technology and to try to evaluate it. And we chose this place. If it's going to work here, it's going to work everywhere in the world. This desert-like place is salinity water, which I remember one of the farmers told me, we are about to grow salt, not fruits or vegetables. And the land they are using is Jordanian land, because we don't have land. So we are supplying them water, and they give us land. So can you imagine, we supply them water? We are a very small country with little resources and no water, but our technologies allow us even to give water to our neighbors. And thank you. And starting there showed us that what we are doing is not only increasing yields or making a healthier food, we are reducing stress. And reducing stress is the #1 thing that we found that it's crucial in this world. And there are farmers here that understand stress. You're getting money from the government. You need to pay back. You need your crops to be healthy. You need to sell them in the market. So we found out that reducing stress, not only for people, but also for the plants, because when the plants are healthy, they are reducing their stress, and then we see that no insects are coming to those plants. They're going to another plants, not the ones that are healthy, that are nurtured and grow in the best way. So reducing stress, collaborating with nature, this is the way that the world should move forward. And 7 months ago, my wife, Professor Hadas, came home and she said, "Oh, we are going to India, the whole family," after she's been here many times, countless times. And I always asked her, why India? What do you see in India? And she always told me one thing: I feel in India like I'm home. And of course I understood what she said, but I couldn't relate to it because I've never been to India. And just the fact that she said it made me very interested in seeing what's happening here. And after she said that, I read an article in the newspaper, in an international newspaper named Globes, that Professor Hadas from Tel Aviv University is going to India for a sabbatical with the entire family. So if I read it in the newspaper, it's got to be true. So I said, okay, I'm going. So that's when the journey started 6 months ago. And before I came here, I said, okay, I'm going to run some trial with our technology in India, just to get the feedback of the land here, the water, and the outcome. How is it going to look? So even when I was still in Israel, we started a pilot in Bangalore with cucumbers, and I will tell you about the results soon, and also Anomaly will tell you his experience with the technology. But again, just to talk overall of things, and talking about reducing stress, and talking about collaborating with nature, this is not just words that we are saying. Collaborating with nature is essential. By using too many chemicals, fertilizers, we are destroying nature. We are destroying any resource that we can think of, from water to bees. If bees are going to disappear from the world, none of us going to have any food to eat. And we need to take care of it. I mean, the cellular towers already doing the job in killing bees. We are not supposed to help them. We are supposed to collaborate with nature to get healthier food. And by doing that, the first thing is quality of water. Now, if you speak to farmers and you speak to agronomes, they don't consider the quality of water as an essential ingredient for the growth, which is a mistake. Thank you. It's a mistake. It's a big mistake. And we know that. We understand it. And in the last decade, what we are doing is treating the water in a different way. You can call it holistic way or physical way, but not chemical way. So this is a very innovative thinking to do things like that, to talk about treating water holistically. And in Israel, which this country is a very practical country, we don't have enough human resources, we don't have any other nature resources, so we need to be practical. And when I met the government in Israel, the agriculture department, and showed them what we are doing, they looked at me like I just fell from the moon. What are you talking about? Raising the DO in the water, giving a physical treatment. How do you do that? What are you talking about? And if you want us to check it, you're going to have to pay a lot of money for the research. And I said, you know, I'm a young entrepreneur. I took this job seriously. And I told the government, you know, at this point, I think that we are not ready to collaborate. So then I went to the Arava area, to the desert area, and managed to convince one of the leading farmers in Israel just to test the technology. What can I tell you? You know, after the first cycle, didn't hear from the guy. He said, yeah, I'm still checking it. I cannot give numbers now. And we have to understand that in Israel, agriculture is taken very seriously. This guy is a third generation of farmers. Any change in their method is very tough to do. And everyone is keeping his knowledge very close to his heart, not telling everyone. But after the third cycle, he became my best friend. He told me, and when we came to his farm with all the engineers and the doctors and all the group and everyone, and he said, you know, now I can talk. After 3 cycles, I can say something, because it's not a force majeure that happened, it's not magic or anything that happened. Now, after 3 times, I can tell you that what you're doing in EcoAeon is amazing. And just for him to admit that he received between 20 to 40% more yield, and using the same resources, if you're getting 30, 40 percent more yield on the same amount of water, the same amount of land, that's amazing. Now, we see the connection, the direct connection between agriculture, healthier food, and GDP of countries. Do you see the connection? You see. Because this connection is a direct link, because consuming unhealthy food full of pesticides and chemicals brings cancer, brings diseases, and then it affects the workforce of the country. And that's in every country, especially in a developing country who wants to lead the world. We need the workforce to be healthy and to produce work. So this is the direct connection between healthier food and GDP of the countries. So this is basically a trial that we ran, but then we did it for over a decade. And just talking to officials in Israel required us to take it to a scientific manner. So it took us few years to validate this technology in the way that scientists can understand it. But what do we understand from that? We are mimicking the nature. What happens in nature for a long time, we are just doing it in a second. But we did, yeah, we did a validation report in Tel Aviv University that basically showed that bottom line is what's happening in the field. And besides that, we can see, I'm not going to get into the technical things, but we see improvements also in some chemistry of the water. For example, raising the DO in the water, the dissolved oxygen, which is crucial for the plants. If the plants don't get DO, they don't grow. Now, to get the DO to the plants, to the root zone, it's very difficult, because the land, when you water the land for a long time with all kinds of water, even gray water that, you know, people think that it's good for agriculture, full of salt, it destroys the land, and no DO can pass through the land to the root zone. So what we saw is an accumulating process in fixing also the land capability of transferring DO. Now, to transfer DO for a long way, this is very difficult. So the only way to do that is changing the water itself, its structure, and keep it this way. So by changing the structure of the water, we are able to get more DO, and not from the atmosphere, just from the structure of the water. And only now scientists from Japan, from places around the world, understand that water has memory. What does it mean, water has memory? It means that water can go back to the natural form if we know how to do it. And if I started by saying holistic treatment, so I can talk to you about structuring the water in a new way by frequencies, which is a new subject to people, but everything in our universe has its own frequency, also water. So the way we are treating the water is with frequency that allows them to remember who they are, where they came from nature, and their natural essence. Trying to explain to people what we are doing, or about frequencies, or about changing the structure by vortexing the water, breaking the clusters of the molecules into smaller clusters. Now, by getting smaller clusters, it affects immediately the amount of the DO in the water. So talking about this novelty, about frequencies, about mimicking nature, that was a very new thing in Israel when we started. After 4 years or 5 years, when farmers and people we worked with ran directly to the agriculture department and told them, okay, you have to take it seriously. You have to understand what EcoAeon is doing. So they came to us now, and they ran tests, and they got amazing results. Now they understand what we are talking about, but it took us almost a decade to do that. Now, with this knowledge, and accompanied by partners from the UK, from USA, that some of you have met, we are collaborating with the knowledge we got from Israel, from Africa, from Asia, Thailand, China, and all this knowledge we are now bringing here to India. And I will let Anomaly later speak about his experience. He just started, but he can already share his experience. And so this is, again, reducing stress that I started with. This is the way that we are collaborating with nature and with farmers, and getting abundance from the same land and from the same quantity of water we are using, and just treating in our holistic way. I'm just going to go briefly over it. just a quick note. We've been here for 6 months. Now we are living in 3 days. So yeah, we are doing the best we can to finish all the things we need to do. So these are the main points in collaborating with nature to create abundance, reducing stress and respecting nature, naturally increasing yield, the way I told you how we do that, increasing profitability and abundance, restoring the natural balance in soil and in the environment, reducing cost and producing health-giving natural food, disease prevention and treatment, reduction of chemical and fertilizer costs while protecting the environment. It's not only the cost, it's the health that we are concerned, and also on the financial side, the costs are being reduced. When we compare our yield to other yield, in every place that we ran some tests and control side, even for example here, you can see the vivid colors of the cucumber, the pepper, of everything. And this is a direct connection to the treatment that we are doing. And if you see this cucumber, this is the cucumber we have in Israel. It's very green, it's very tasty, crunchy, and this is what we are used to eat. And we are bringing it to India. Yeah. So restoring the natural balance in soil, as I said, it's most important, and it's an accumulating process. And also to do that, we are using a specialized biochar to be mixed in the land. And the biochar works perfectly with the activated water that we are supplying through our missions. Well, disease prevention and treatment, which is a crucial thing for farmers. We came across banana plantations. We just had a disease, treating them with our technology, got them back to work and produce healthy food again. And this is not only doing with the activated water, but also with the biochar mixed with microbes, and we are using natural resources, nutrients that are patented to our company. And all of these microbes that we're using that are part of nature, with biochar that is a part of nature, and the nutrients that we are using, this is how we see the collaboration with nature. Well, this is very known process of the fertilizers ruining the environment. As you can see, the whole cycle of fully filled fuel getting to the atmosphere, then going back to the land, including the fertilizers, and this is reaches back to the water, back to our resources. So we are trying to avoid this vicious circle. This is just an example of a sugarcane, which is also very important in India. For example, of one ton of sugarcane in a standard method can yield about 9% of sugar. Using our activated water, yield between 16 to 20%. So can you imagine that to almost twice of the amount of sugar from the same land, from the same number of sugar canes. So this is exactly an example of what we are talking about. When the plant is, we give him nutrients and it's nutritious, then it yields more and healthier food. Again, disease prevention, when we saw in Malaysia, in cocoa, which we were able to treat. Now this is the symbiotic application I was talking about, and using nature's gifts, water activation technology, what we are doing, alongside to eco biochar, eco nano, eco nutrients, eco bacteria, which are soil-based organisms, and using this with our technology basically help us to reduce stress again and reduce chemical usage and provide people more healthier food. And just to conclude my talk, again, in a developing country, it's crucial that the food will be healthy, that the people will be healthy, that the country will develop, and force work will develop. And this is our humble way of trying to accomplish that here and around the world. Thank you very much. Thank you.
Actually, our engineer Annamalai 76 technology, he has already applied this technology, and I request him to validate this technology within 5 minutes. Professor Hadas has to follow it.
Okay. Good morning to everybody. I am Annamalai 76 Chemical. I have been doing agriculture near Pudukkottai. I am doing agriculture in 45 acres, but I conducted this trial in my poly house. I have two poly houses, one of 1000 square meters, other one is 2000 square meters. I conducted trial on 2000 square meter poly house. This equipment was earlier tested in Bangalore in open field, I was told so. But this is the first time it was tested in poly house in India, in my area, in my land. And they advised me to use this SEM water right from day one. But when they supplied this equipment to me, my polyhouse was giving full yield. That is, I had 24 rows of plants. In each row, I had 160 plants. So 24 into 160, that is the number of plants that they were yielding, and they were in peak yield time. But they said that this equipment should not be used it should be used only from day one, from the day of sowing. So I removed the plants that were giving me yield. 6 rows I removed, that is one fourth of the yielding plants I removed. I fixed this equipment and bought again seeds. The seed we get from Netherlands. Each seed costs 7 rupees. 1000 seeds I bought and conducted trial in 6 rows. And the trial is not fully over yet. Normally the cucumber plants, they give yield from 36th or 38th day of sowing. It's almost, now I have taken out one pick only I have done so far, because it was installed about 40 days ago. One pick I have conducted. I am yet to confirm whether it gives 40% extra output or not. But certain things I observed, I have to admit. It certainly is much better than, it gives water which is much better than normal water. That is to be accepted. Because with normal water, we used to supply quite a lot of fertilizer. water soluble fertilizer we used to dissolve. From 12th day of sowing the seed onwards, we used to supply fertilizer every day from 12th day onwards. But it is almost 40 days now. They advised me not to use fertilizer. I tried that for so many days, for about 30-35 days. I did not give any fertilizer at all. The plants were okay, but somehow I developed some doubt, and I started supplying fertilizer for 5 days. They came to know that I am supplying fertilizer. They told me to stop. From that day onwards, again I stopped supplying fertilizer. The plants are healthy, but compared to, we conducted 3 rows with SEM water, only SEM water. This equipment, whatever water it supplies, they call it SEM water, SEM, SEM water. 3 rows with SEM water only. Other 3 rows, 50% of the rows with biochar and 50% without biochar. In that also, in 1 row, we supplied sprayed one chemical they supplied me. It is called NS1. For first row, 50%, that is 80 plants with NS1 only, and another 80 plants with biochar and NS1. Second row, they supplied another chemical called Bio Nano. So 80 plants with SEM water and Bio Nano, other 80 plants with biochar, Eco Nano and SEM water. Third row, only SEM water. 80 plants and other 80 plants with biochar and SEM water. Like that we conducted, I am conducting trial, but I observe the plants are healthy. And another thing I wanted to stress here is that in the earlier methods, we used to spray pesticides and insecticides every week. That is from 12th day onwards. From the 12th day of sowing onwards, we used to spray pesticides and insecticides every week. But here we have not sprayed any insecticide or pesticide. So plants are healthy. Only one disease so far I observed in 40 days is that some plants are affected by red mite. Probably in Israel they don't have that disease, so they have not prepared the solution to resist red mite. I don't know whether it is true or not, but only some plants are affected by red mite. But had I not used this water, had I not sprayed whatever they have given, by now I would have lost about 60 to 70% of my plants. Without spraying pesticides and insecticides and without giving fertilizer, water soluble fertilizer, in our method it is very, very difficult to get yield. But I am yet to confirm whether it gives 40% extra output or not, because I have done only 1 pick. I am yet to do another 40-45 picks. Only then I will be able to conclude whether it gives 30% or 40%, I do not know. But certain things are true, that this SEM water is definitely better than normal water. And I also conducted this, supplied this SEM water for some tomato which I planted in the open field. Those tomatoes are very good. Those plants are excellent. And normally, compared to normal tomato, the tomato plants which were supplied with SEM water, they have started giving yield 5 days ahead of normal schedule. And the plants are healthy also. So this is my observation. Let me complete the study and then give you feedback after 45 days. Thank you. Thank you very kind of you.
Thank you, Annamalai sir. Question hour, after the 3 people have completed the presentation, we can...
Anything related to this, you can ask me afterwards.
Yes,
I will
yes.
tell you.
Professor?
Okay. So, hello everyone. My name is Hadas, and I'm a visiting professor at the IIT Madras, so it's just nearby, in the civil engineering, environmental engineering department. And my research is generally on water and wastewater and improving the quality using a combination of advanced and less advanced technologies and trying to improve technologies. I'm also working a lot on wastewater reuse and also working a lot on analysis of water quality and wastewater quality. I'm originally from the Tel Aviv University, and Tel Aviv University is a special university because it is also ranked number 9 in the world for the most amount of startups that gained a lot of money from their startups. And this is the only university outside the U.S. So it's ranked in the top 10 with Yale and Princeton and all these universities in the issue of startups. And this is, I am in the Faculty of Engineering, and we're actually very much geared toward not only doing research, but also implementing. As a scientist, I do not see the point of only writing publications. So we must reach, and there must be a bridge between the scientists and the people that are working in the field and the industries in order to try to improve processes and things like that. Today, I will talk about wastewater. And the reason is that water is highly discussed, and many people talk about water, but they talk less about wastewater. And also you'll find in many places in the world more water engineers, but less wastewater engineers. And actually, what my message is and what I'm trying to talk about a lot in India is the issue of using wastewater as a resource. And wastewater must be collected, treated, and reused in the environment. And there's no other way to combat the global water crisis. There's no other way. And and wastewater, which is not treated, also contaminates our water sources. Specifically, in my country, we collect 90% of the wastewater. 98% of the wastewater, but this is not like a big issue. This is done in many other countries. I mean, developed countries. But we reuse 90% of the wastewater. And this 90% of the wastewater that is reused actually is our only way to combat the droughts that we suffer. We're in a semi-arid country. We do not have any water sources. We don't have rain. We don't have nothing. So this is our only way actually to provide water. And I'll talk a little bit about this. And just also to let you know that we didn't start like this. So about 30 years ago, the wastewater collection, maybe 40 years ago, was around 30%, like the current situation in India. So if you consider that, about 70% in average of the wastewater in India is dumped to the environment. And you can see it in the Buckingham Canal, you can see it in many other places. So this is a situation which should not be accepted. And each one of us has a role in conserving our environment. And if you look at what India was in the past, India was connected really to nature. And this connection is somewhat lost when the environment when we have wastewater released to the environment, when we have solid waste, also issues with solid waste, and when the sludge is also not treated and dumped. So all these things must be treated. And India is one of the most growing countries. And all of us, since we're chemical engineers, I think most of us, we have a role in this country. And I say it almost as my country. We have a role to take care of the environment and not let only the people that work with IT and stuff like that develop their technologies. They must also look together with developing the environment. And if you look at the situation of Bangalore, for example, it's considered one of the most advanced cities with relation to IT. But if you look at the environmental situation, it's very bad. And if the environmental situation will not be solved, then it will not be anymore an IT hub in the world. So that it was proven so many times that the environment goes together with technology. So all of us have a role. And I can tell you that in Israel, the NGOs fought the government, and they took lawyers that suited the government in order to treat the environment. So things can happen, and if people unite, and many people fight against things that are not happening correct, then a change can happen. So I believe in change, and I'll just really quickly want to show you, because my idea now is not to talk about science. I would gladly come some other time. I'm coming to India many times to give more lectures about science, but I want to give a message which for me is more important. And I also don't care to speak out my mind. I will say anything that I think, and I'm not afraid of anyone. And so for me, I think that everyone has an environmental mission to keep nature and to keep the environment, because our children will be affected by this. And India is affected. So if you talk to doctors, they say that children cancer is on the rise. And if you talk to doctors, they say the children under the age of 5 are dying due to environmental causes, which could be air pollution, water pollution, and wastewater. So this thing does affect. It does have an impact. And therefore, I think we have a mission and a role, and also looking at decentralized wastewater treatment plants. So it's not always looking at the big plants. It could be small, decentralized, efficient plants that could help the environment in order to solve many issues. Because many places are far away, they don't have, and also looking at solar energy, looking at these things, this is possible. This is not impossible. If we were able to take a desert and make it in a country, and we got independence at the same time as you got. And I acknowledge that you're a huge country, but we all must take our role to protect the environment. I would really like to talk just a little bit because I really have to leave soon. But if we look at the trio between the industry, pollutant, and treatment technology, so we know that the industries generate pollutants, and the industry could be also domestic industry, our wastewater. This is also an industry, and we generate pollutants, and these pollutants must be treated. And because India is on the rise with its industrial phase, then we have more wastewater and more pollutants in the environment. So wastewater is a combination of liquid and water transported from homes, commercial buildings, industrial facilities, institutions, and also groundwater and surface water infiltration. And as you know here, everyone almost here is a chemical engineer? All kinds of engineers. Okay, so I'm in the right environment. There's many type of industries. I'm sure you can relate to the dairy and the pharmaceuticals and the leather tanning and oil and gas extraction and food and beverage industries. And these industries actually produce a huge amount of contaminants. And these contaminants are really huge, so the list is actually endless, the amount of contaminants that are released to the environment. And the treatment technologies are also enormous. So we can have absorption technologies, we can have advanced oxidation, which is what I'm doing basically in my research. We could have aerobic, anaerobic, biological treatment, chemical precipitation, membrane filtration, ion exchange, hydrolysis, whatever, distillation. There's a huge list of treatment technologies. And therefore, we must pair between the industry, the pollutant, and the treatment. So for example, to remove chromium from electroplating effluent, we need to use a technology, for example, that maybe can absorb the chromium. But then we must look at the residuals. We must see how the sludge is also treated. And if it's dumped back to the environment, then actually there was no treatment, if you consider that this way. And also removal of arsenic and textile wastewater, all these must be considered. So how can we match between the industry, pollutant, and treatment? So if you look at this image, actually you see a puzzle. And in this puzzle, one piece is missing. So how do you actually put the piece that really connects to what you're looking for? And our goal in treatment technologies is actually to find synergies. So we all learned that 1 + 1 = 2, but 1 + 1 can be more than 2. If we use the synergy of technologies that could really help the environment. And there are many challenges. We know that the water supply, as I said before, receives a lot of social and political attention, but the wastewater management does not. And this is where I think things fail. The wastewater management does not receive as attention as the water. Now, some people that I spoke to in India actually say, we oppose wastewater reuse. But I can tell you this, if the wastewater is not treated, then it is anyway, it reaches you in some way. There's no way that you can oppose wastewater reuse in India. There's no way that this could be opposed, because if it's not treated, it's just dumped as is to the environment. So it will reach you in some way. And therefore, wastewater management, especially in the context of water scarcity, was acknowledged by the UN Water Development Report in 2017, is the only way to combat our water scarcity, even if you like it or not. So neglecting wastewater management can have harmful impacts on sustainability of water, human health, and environmental economy. At the end, this will also impact the economy. So there's no way around it. And so the challenges are also global and local. The contaminants are endless. I would like not to talk specifically. I can maybe talk a few minutes about what I'm doing, but I'm developing technologies that actually oxidize those pollutants by using reactive species in the water. And these reactive species, if you think about this, in our body we can form many oxidative species. Okay, so for example, I'm sure you heard about the free radicals that are formed in our body. And these free radicals are actually have a high oxidizing potential. So they will take electrons from anything from our body and actually degrade our cells. And therefore we consume antioxidants, which in our food, in order to neutralize the effect of these free radicals. But in the water, we actually utilize the power of those advanced oxidation processes in order to break down contaminants. And I will just maybe, just to talk about just a few more notes, and not generally on my research. As I said, I can talk about my research at some other time. But for sustainable water reuse, we need to reduce, recycle, and reuse. There's no other way. And water reuse is actually taking non-potable water that is highly treated and used for approved purposes other than drinking water. So it could be for drinking water, but generally speaking, it's for processes other than drinking water. And where could we reuse wastewater? So reused wastewater could be used for irrigation, for industrial use. So for example, if there's a wastewater treatment plant near an industry, and this wastewater treatment plant actually is operated correctly and maintained correctly, this water can be used for the industry. And this is where things must be taken care of. There's no point of treating the wastewater, getting high quality water, and then dumping it to, I don't know, to the sea. So there's no point in that. It could be reused and used as a water source. And also looking at recreation. And there's also the non-potable, there's non-potable use, and there's also the potable use. So the potable use is either for drinking or not. So many countries in the world oppose drinking treated wastewater. But for example, if you look at New Water in Singapore and also in California, they actually drink the wastewater that is treated, and the water is at a very high quality. It's actually, it's not like that. If you look at the treatment scheme, and maybe some other time we can discuss these issues, it's not that we're drinking directly our wastewater. It's not like that. It's being treated in a very high quality, and then we have like a residence time of 2 months together with water, and then it goes to the water treatment plant, and only then they drink it. So, but it really helped. And why is wastewater so important as engineers? Huh?
Low TDS when compared to seawater.
First, that's true. We have also low TDS. And another thing, we generate wastewater all the time. So I'm sure all of you will agree. And if you have an industry that has a constant source, this is a very good thing. So I would say that to my opinion, and again, I'll talk about my research at some other time, but to my opinion, we must make sure and try to find every way that the wastewater is being collected, treated, and reused. There's so many applications where wastewater can be used. I can tell you that we were approached to, in Chennai, I cannot say where, but we're approached on how to use wastewater, for example, for cooling water. Because the water sources will be more and more limited. You must acknowledge this, okay? And I would like to just maybe end that global water reuse is being used in so many places in the world. And just a few more slides, I would like to tell you about the situation in the Middle East. We're going from one drought after the other. And just consider this. I'm sure you acknowledge the global climate change. Things will not become better. And also the issue with the plastics, things are not becoming better. If we ignore treatment of water and wastewater, then the situation will not be good. And if you want to raise as an economy, and you're the largest country in the world, I think, and you have the largest amount of young, talented engineers and people, you can do everything that your mind is set on. So this is my message, and that's it. Thank you very much.
I think we have met a revolutionary woman. We have to take her to US to teach the very bad environmentalist, Mr. Trump.
Maybe needs
You agree? You agree with me?
I agree with you, yes.
Thank
Yes.
you, thank you, thank you. Actually, Mr. Stephen Barrett is waiting. Just a minute, sir. And our two other distinguished delegates, they are moving to, I think, for other programs. If you can, we'll have the question hours. If you have any questions, we can pose the questions to both of them. Vinayaka Murthy, ஏதாவது கேள்வி இருக்கா? Ravi, please. நீங்க பேசுறீங்களா உங்களுக்கு? சரி.
I think to Hadas, I think you said about this AOP, this advanced oxidation process, but how effective it has come to implement for treating this maybe like all this heavy metals, like because AOP is an advanced stage. I think maybe the R&D is completed, it has came to society level, or still like more number of R&D, because I have done my UG level project on that, and we used the same technology, and we have broken the particles of heavy metals into pieces, and we could able to treat it, and that's one of the wonderful technology. But for the real time, like need of the hour, so for the basic wastewater treatment, how does this can be implemented?
So I currently, advanced oxidation is mostly a tertiary treatment. I think that in the current situation, they can only fit the industry. I would say that the most burning issue is to collect the domestic wastewater and treat it at a secondary level. And these treatments that I'm working, they're tertiary treatments, so they come after the secondary. So therefore, I would say it's a burning issue from my perspective, is first to collect the domestic wastewater and treat it. And after that, we can worry about like taking care of the residuals. Yes.
It has become like a big mountain.
I know.
Nobody doesn't know what to do that. Until they created as a mountain and full of grass they created, and it's like a mountainous sludge waste being dumped there. So maybe as I said, primary we need to treat this cover thing. And industrial waste is very important where they're coming and dumping in the residential area, and it's becoming
So the industries have more money for these type of technologies, but the domestic wastewater will not have the money to implement these technologies. I would say first to take care of collecting the wastewater and treating it. This is the first step. And finding where to reuse the wastewater. From my opinion, this is the most burning issue.
I have one. I have one request for both of you. See, we are mainly depending on Netherlands for seeds because in polyhouse we need only self-pollination seeds. We can use only self-pollination seeds. But in India we have quite a lot of varieties which are cross-pollination seeds. To use that, we want to use our own seeds. So, but our own seeds will not give fruits inside the polyhouse. For pollination purpose, we cannot use our Indian bees inside. They don't stay inside. But I am given to understand that in Israel, they have developed one bee called bio bee. You heard about it? I don't know. So I am told that there is one bee called bio bee. So I would be grateful to you if you can supply us some bio bee so that we can conduct trial as we did with SEM water. We will conduct trial with bio bee also, and if it works well, we will be able to buy it from you.
You're right. That's the next step to make sure that the seeds will do the work here. And me and Balam already contacted an Israeli company that supplies seeds and specialized seeds. We're going to do the connection. We're going to do the connection.
I do open farming, and I'd like to know whether this SEM water will be same for all the plantations. Like I do banana, coconut, grapes, all sort of plantations.
Everything.
So will the structure of the SEM water change according to the soil, or how do you do the soil testing and then change the water structure?
We are running some soil testings and also water testings to identify any problems. Sometimes a pre-treatment is needed before connecting the technology. But basically, all plants are working in the same method. Just the nutrients around it. And the biochar is different in different sorts of situations. But the SEM work to the water is the same water that we are supplying to bananas and to fruits and to vegetables, the same thing.
So how do you the water, it's suppose it's an open well, you mix this water with open well, or does it get treated with the...
No. If you work from an open well, you're going to need a pump to pump the water, and then this water because you have to understand, we are not using electricity in order to get this water. We just need 2 bars of pressure. So if you have a well and you can connect the pump with 2 bars, that would do the job.
See, it's a SEM water. SEM is a small stainless steel jar within which there are ceramic balls. The water is passed through the jar, so it gets vertex motion. Because of that, water's quality is improved. That's all. So whether it is open well or bore well, you have to pump water through this equipment. The water that comes out of that equipment is called SEM water. That's all.
And it's just a mission, but inside there are a few patents that how we activate the water. It's not only mixing. There are no chemicals or no electricity.
So what is the cost of?
That's a very good question.
Yeah.
Which we will have the answer in a few days. Because to make it localized, we are starting to manufacture the technology here in India. With doing that, we're going to localize the numbers, the prices. So
the thing is, last 40 years I'm cultivating paddy. So ancestors also cultivated paddy. I'm 35x cultivating.
I see. Now the price, everyone has to keep in mind that price, of course, is essential, but this technology can last for a lifetime. I mean, and just keep in mind that in each cycle, you're making between 20 to 40% more yield. So each year, you're putting 3, 4 more cycles a year. The ROI is very short, but it stands for a lifetime. Now again, in order to achieve this kind of results, you can imagine that this is not something that that it could last for 20 years or a lifetime. This is not just materials that can, vibrate into
No,
the air.
approximately
So I just to give you an example, one of the minerals inside this machine, out of 82 minerals, is $1 million for 1 ton. So this is to get this effect, to get this result. We use the best materials that can be found on Earth.
No, approximately what will be the cost? Because last two decades we are cultivating, we are unable to get profit at all. The yield is very less. What we are spending through paddy is very less, and also due to a lot of climatic conditions we are unable to get profit. And also the paddy level is depends upon the climatic conditions, yield also well less.
Yes, sir.
So let me know what is the cost
Do you have
approximately.
a business card? You have a business card on you? Business card?
Yeah.
So
I am
whoever is
basically
interested,
mechanical engineer working as an associate professor in government aided polytechnic. Besides,
good.
I am doing these things.
Okay. So you can
Sure,
be
sure.
in touch with
Yeah.
Balam. We are now working in Hyderabad to finalize the production here. I don't want to throw just a number in the air, but I can tell you, if, for example, you're buying a car, Mahindra or Mercedes, it's something in between.
No, it is near Tiruvallur only.
Sorry?
So my field is near Tiruvallur only. So not from 40 kilometers. Yeah.
Yes,
Sure.
please.
Sure. Yeah. Thank you.
I'm also going to leave some business cards here if anyone has questions. Balam is here.
Only one
Yes,
question
yes,
allowed.
I'm going to leave my number. And again, anyone can reach Mr. Balamorgan. Thank you very much. It was a pleasure and my honor to visit you today. Thank you very much.